So here from the lab, work under Eddie Barker and Hank Kafka in the Access Technologies organization. So Ed has graciously agreed to come here and take us through some of the information. There's been a lot of pronouncements on this technology recently, so it'll be good to get a briefing on it. A couple reminders before we start the call. Number one, all of your mics are muted, locked. If you'd like to ask a question, please send me a private chat note just to me, and I'll cue that up for Ed. You can try the raise hand function as well, in which case make sure your audio and your web are linked together. And finally, if you would like to follow along with the slides, they've already been posted up on TechSpot. So with that, let me introduce Ed Walter. It's all yours, Ed.
Thank you, sir. All right, so as was mentioned, I'm Edward Walter. I work in, actually the labs is the known term. I guess we're called Technology Design and Architecture. Been working on this Access specific technology since probably around 2005 when we first started kicking off the Lightspeed project as a whole. So we've had, the reason for the conversation today is really around activities that really started to spin up. We've been doing PON since A-PON, and then B-PON rolled out, and then started doing G-PON. But we really felt the desire to push this harder around 2013. So when we had, and that was a direct result to some competitive pressures in the market. So and that came out with a gig, 1 by 1 gig service offer. So with that history on that, that's kind of why you see so much more activity in PON today than we did in the past. I mean, we had a lot of people working on it in the past, but really never gained the traction from a deployment standpoint. Historically, we deployed before pre-2013, we deployed most of the stuff was greenfield. We'd go into areas, new subdivisions, and they had to actually even meet a certain criteria, so it wasn't even all greenfield. And then we'd investigate or leverage the PON technology that we're going to use. And I'm going to talk about the vendor in particular throughout the deck. And then after 2013, it became more of a greenfield overbuild, specifically tied to the $12.5 million commit to the FCC. So it became more of a brownfield overbuild solution as well, which was new for us. But I'll talk more about some of the stuff in the deck here. So that was just giving a little historical context. We've got, I guess I'll walk through this slowly. I've got. There's two avenues right now kind of going on in PON. There's always the development or design standardization around new optical improvements to get better broadband speed. So today we do GPON, it's 2.5 gig. In the future, we want to evolve to 10 gig, 25, 50, 100, whatever the next flavor we decide to implement. And then there's the other thing. I think everybody understands that throughout the company there's been a push for SDN and network function virtualization. So you'll see down below, you'll see an SDN and VNFs. That's just a function that would have traditionally been found on a box. They want to move it to software-defined platform. So we're going to talk a little bit about that in one of the sections of the training as well. So you'll see those two factors playing out in anything development-wise that happens moving forward. There's always a time to market issue, so often you have to account for that when you make decisions around your medium time frame architectures. So we'll talk a little bit about that as well. So let me go ahead and jump to the next slide. So some of the kind of the objectives we have from labs and working with our partners over in planning when we start working on the next or the evolution. So everybody saw, I'm sure if you didn't, you can Google XGS press releases for AT&T. You'll see that we've had a couple out in the trade magazines lately. I actually speak on it usually when I go to Broadband World Forum or OFC. So we've gotten the word out that we are definitely planning to move to XGS PON. Right now, like I said, we do 2.5 gig / 1.25 gig GPON. We're moving to a 10 by 10 gig PON. The goal was part of this wasn't about technology. It was about getting technology at a price point that would make it attractive for us to deploy. So we've successfully done that. So you'll see through these things here our tenets or our goals as we design PONs or try to move to the next PON, right? And since 99% of what I talk about for PONs is consumer based, and even the HISA that we sell to business looks very similar to the consumer-based solution. So no, we don't currently today put any SLA-based traffic on our pond. Ace over pond stuff, none of that is currently being planned or planned to be developed. So when I talk about ponds, I mainly talk about best effort. But you'll see some of the things we're doing here. We got SDN NFV. That's always a tenet. We work in part of our job is D2. So when we look at this, we've got a lot of activities going on in that. We'll talk about this in this deck about the activities we're doing in the D2 space. We also tend to look across the board. Part of the work I do in standards and my counterpart, Kent McCammon, do is we spend a lot of time at the ITUT standards bodies as well as the IEEE. And part of that is to, while we dictate or try to drive requirements, we also canvas the requirements from other operators with the goal in mind of trying to line up on where the volumes of optics go. Because, in PON, the one big killer for cost is your optics cost. So that tends to be a driver for us. So you understand kind of where XGS came from. We lined up where we knew the largest user optics is, and that's China. China tends to drive hundreds of millions of optics. And so if we line up on those where it makes sense, then we tend to get we enjoy the cost benefit of picking those volumes. Automation, this is Indigo D3, looking at ways to, probably doesn't affect the customer per se, but it definitely would be useful if every time I went through a tech dev development effort, I didn't pay and start from square zero again. So we try to find ways to automate. This is something that we're currently looking at for D3, like I said, with Indigo. Edge compute. This one is relatively new, mainly because we are looking at ultra-low latency applications. I've got several meetings planned and places to go to look at wireless support over PON. This is a relatively new topic, so I don't really have a lot of information on that other than this is going to be extremely low latency beyond what we currently do today with consumer. But it is something that I'll kind of briefly discuss just so you can understand where Labs is going on the PON front.
Hey, Ed, could you just clarify, is Edge Compute, AT&T Edge Compute, is that the new name for AIC? Or is it an overlay to AIC?
No, so let's just keep it. So AICs tend to be the data centers at certain points in our network, call them at certain COs. They're not everywhere. AIC did propose an edge compute option. That doesn't mean that will be the edge compute option. There's also other ones out there called AEC and some other ones right now I'm not allowed to talk about. So let's just say there is going to be an edge compute design somewhere being driven by a service application requirement. And our goal is to be able to leverage that. I don't know that we're not going to be funding the development of edge compute within the PON platform, right? We're going to do the PON, the access, but because of latency sensitivities like 5G with a certain optional split, if you're following any of those standards, there are, microsecond latency requirements, which are very tight and that's just round trip, not the service. But it is significant latency requirements that will force stuff to be pushed out to the edge. And if you've listened to the president of Labs, Andre Fuge, ever talk about this, he's big on this as well, right? I think we all see that latency is going to drive things to the edge, and our network tends to be perfectly positioned for that. With over 5,000 COs, we tend to have that. And of course, getting the cost down per installation is the biggest problem right now. But the goal is to support low latency applications with some kind of an edge compute service, and whatever that may be, because that's a little bit in flux right now, depending on which way we end up going there.
Okay, very helpful. Thank you.
Yeah, and then the open vendor interoperability is always kind of nirvana for us. In the PON space, people throw around 988 standards saying, okay, we've got interop between ONT and OLT, but the problem we run into often there is it's just the interpretation of the vendor. OMCI is written in a very, and for those that know, OMCI is the communication channel between the OLT and the ONT. You actually always talk to the OLT, and the OLT talks to the ONT from a management perspective. That OMCI does everything. There's MEs in it that are managed entities that will communicate between the two devices. So it tends to be a bookend solution. And some vendors have been some operators have been more successful than others at implementing various mixes of ONUs in the standards that come ONUs, ONTs with OLTs. But in the case of AT&T, we've always just had one vendor in that space. But that doesn't mean that we don't have a requirement for open interoperability. And in fact, we've actually published an open OMCI spec that we're going to start using with any vendor that we work with, and I'll talk about that when I get to the D2 stuff. The last piece is really around PON convergence, and this is because I mentioned earlier that I actually attend the IEEE 802.3 CA task force or task group. It's a PON group under the IEEE that is currently focused on 25 gig, 50 gig, and 100 gig PONs. For most of us, we look at it and go, where am I ever going to use a 100 gig PON for consumer? But this isn't necessarily about consumer play, although some people are looking at it that way. Our interest from AT&T is really about, is there a place with a 50 gig or 100 gig PON supporting a 5G backhaul or some kind of a 5G design solution? But more to come on that. That's still ways out from a standardization completion effort. We're probably still 2 years away. On the ITU-T side, there's a lot of activity as well. That's through what they call Standards Group 15 Question 2. And that group does pretty much all the PONs we deploy at AT&T. All our PONs are really based on ITU-T designs. We don't really use IEEE. That tends to be a cable MSO design that's used with DOCSIS. We tend to use, also using DPoE. We tend to use IEEE or ITU-T. Most of the telcos use ITU-T, and that's kind of why we attend those and support those through our activities as well. But they're also just now starting to look at what's the next step after 10 gig PON. They've got two in the plate right now. One is NG-PON2 with multiple wavelengths. And then you've got another one called XGS, which we're employing or going to be deploying. And that is really using a hybrid approach, which was kind of using the IEEE PR30 optics that are single wavelength 10 gig and buckling them onto the NG-PON2 MAC. So it was kind of our first attempt at a hybrid approach. It went through the standards, got ratified last year, and we're actually developing it right now at AT&T to deploy sometime in late 2018. But what this really drives is when they say PON convergences, you've got two standards groups building PONs, and the vendors in particular really would like to see some convergence of the designs. They don't get rid of standards organizations, so the standards groups don't go away, but some agreement between the standards groups to land on specifications that are the same. And this sounds relatively simple. For most folks, you would say, yeah, that's an obvious thing, but in some ways, this is like two rival high schools trying to get them to talk to each other. Both groups have a lot of smart PhD guys working on the stuff. Both think they're smarter than the other guy. So this is an activity that AT&T is pushing hard. I'm actually the liaison rapporteur between these two groups trying to get them to play nice. So more to come on that, and the hope is with 25 or 50 or 100 gig that when the IEEE pushes theirs out, the ITU pushes out something that's very similar to it, so you don't end up having two widely different solutions. And this is probably going to really just be at the optical, physical layer and the MAC layer. I doubt we will probably converge on management, although there is talk about doing that with NetConf Yang through the broadband forum, BBF, at some future date. So let me, I just kind of talked a lot to this, but just so you can visually see it. On the standards, you've got both the IEEE efforts, like I mentioned. Right now, they had finished up the EPON in 2004. 2009, they did a 10 gig PON EPON, which was a 10 by 1, and then they're now working this between the 10 gig EPON and the 100 gig EPON. This is that mention of the group, the 8023 CA group that meets every 2 months to continue to evolve the standards for this higher level support. just note the 100 gig PON is pretty hard to do technically right now. I mean, with enough money, you could probably do anything, but the reality is the problem to get to 100 gig is it's just exorbitant. So this may take longer. That may be the hardest piece to solve in the equation. The 25 and 50 gigs should be relatively straightforward, but the 100 is going to be almost impossible with the technology today. So up above, you have FSAN. This is a full-service access network. This is a group of operators that have been meeting for a very long time to discuss requirements. ITU-T, we usually feed those operator requirements into ITU-T. As you can guess, we are a board member on FSAN. We meet with the likes of Verizon, British Telecom, Malaysiacom, Orange in Paris. It's all the big operators. They tend to attend FSAN, drive the operator requirements into the ITU-T, and that's where these requirements, these technical designs come out from ITU-T based on the operator requirements. So as you see, we tend to like this approach because it takes into account the operator requirements when we develop solutions. The FOAS, or Future Optical Access System, you see far to the right, we've started pushing this around. Now we actually partnered up last meeting with the ITU-T and proposed with a vendor work on a 25 gig PON, mainly because of the work going on IEEE. Right now that's generated a lot of conversation, so whether it's 25 or 50 or something else, that is kicked off now, and I assume that would be the Future Optical Access System. I also assume it will be before 2021, since we're trying to use it for 5G backhaul. So I probably won't spend a lot more time on this, other than if people have questions, I'm more than willing to send you additional information on the standards. But it's a big part of our life over here. So I apologize now if I'm going to make this simplistic and people are going to get bored, but I'll try to get people grounded on the pieces we have here. So if you look at in the standards, there's really three components to the PON. One is on the left-hand side, you'll have some kind of active electronics and OLT. In the middle, there's something called an ODN, or an optical distribution network. In this case, I show a coexistence element and a splitter, but it's the fiber, it's everything. It goes from the frame in the CO, where the fiber would start right off the PON port of the 7342 or 7360, and it would cross miles of fiber, splitters, and then it would eventually terminate on an NTE device on the outside of the customer home. From there, the third element is this ONU device. It can either go inside the house, as we do today with GPON and the ONOs from Nokia, or we can go on the outside of the house and deploy 240, or even go back a little farther to 210s that we've got deployed. But it would go on the outside of the house, and that's kind of your major components of a PON. And whether it's XGS, single wavelength, or it's GPON, or it'd be a future single wavelength 25 gig, the overall design pieces don't change. You still have something on the left that's active, you have something on the right that's active, and in the middle you got a passive ODN network. So what I show here is really kind of, and I probably should have put some more introductions on the XGS, but I thought it was relatively straightforward. Didn't put a lot of extra information in, and I was planning to really just talk to it. So what I've got here is we don't deploy coexistence elements today. So what you would see is a GPON OLT, and it would have a straight line basically to a splitter, and you'd have a 1x32 split, and it would feed nothing but GPON ONUs. And I use 1x32 because that's our design criteria, but it depends on the reach. So as I get farther away from the OLT and the ONU, between the OLT and ONU, I use split reductions to gain additional optical budget. So everything is done based on optical budget. As I start to lose optical budget, the farther I get out, what I will do is I will eventually lose receive sensitivity on the ONUs and the OLTs, and the signal will drop, and I won't be able to make connection. So what we do is we throw a splitter in there, like a 1x16 at a certain distance, and that PON would then be 1x16 driven to give us additional reach. And then when I find that I can't engineer to 1x16s, I go to a 1x8. And after that, then I say, well, I guess I'm going to put a shelf in. So at some point, I will actually make a decision, or I won't. The construction engineering guys will make a decision on placing a remote OLT. And we'll talk about that too. I actually have a picture of an FX8. It's a 7360 shelf. So we'll talk about that briefly. But what we're trying to move towards is using a coexistence element, which is just a passive, basically, splitter device, reverse splitter, like a diplexer. That I show two elements here. It could be more. And then what you do is you have inputs into the coexistence element, and you have a single output to the splitter. Now, you say, well, how does that work? Well, what we have is you have down below, you see the spectrums. So I only show the upstream, but there's an upstream and there's a downstream, but just to make it fit on the slide, I just showed you the upstream. So there's actually two wavelengths, all right? So for GPON, you'll have this 1310 nanometer center wavelength, and it's 40 nanometers wide. So they have some narrow, but what I'm showing here is the reduced, which is what we deploy in our network. There is, in the standards, you have something just called, just a wide upstream, which is 100 nanometers. That was very early in the process. Nobody really ever deployed it. And then you had the 40, which we deployed exclusively or heavily. Most of us do, most carriers. And then you have what they call a narrow GPON, which is from 1300 to 1320. Not a lot of people have deployed that. So what I'm showing here is kind of what we deploy, which will be 40 nanometers wide. And then when you look at the XGS, this was important because we really wanted to use a coexistence element to grow. Hang on a second. Okay. So we may want to use the same fiber, and I'll kind of talk a little bit about why. And then we can just place the XGS stream of 10 by 10 gig on the same splitter by using this coexistence element. It kind of merges the two wavelengths together, and then I put it down the same fiber, and then it comes out the splitter and gives me the ability to change out ONUs when a customer orders service. So why do we do this? So I'll give you a little history. So when we went from BPON to GPON, BPON was the initial, after APON. I'm not going to count APON. So BPON, we deployed a significant amount of BPON. And then when we decided to go to GPON in the 2005-2006 time frame, with our first 7342 shell from Nokia, we didn't have a way to migrate because the wavelengths stepped on each other. So what ended up happening is we had to go out in every case and put new splitters in with new PONs, and PFPs started getting filled up to the point where you had to do grooming and everything to support the additional customers, even if you were swinging them. So it was a mess because you didn't have any flexibility to collapse down your customer base. Well, with this coexistence element, it gives you the ability to run the next technology as long as you've got wavelength multiplexing going on where you're not doing some kind of time division. You can actually just slap in the next ONU at the next service requirement or request, and you can migrate to the next technology without having to mess around with, putting in a new splitter. I'm going to caveat, this is not there today, right? This is a design concept that we're pushing to get funded. It isn't quite in a development stage, but this is a target architecture for us. Use the CE to allow us to migrate to the next technology. And when I talk about 25 gig, I'll reference this again, to allow us to do graceful migrations at the PFPs without having to go in and groom them or, heaven forbid, have to do something more significant to the PFP. So this is our plan for the future. And most as I just talked to you around the wording on the slides. So, yeah, like I said, if you've got any questions on this, I can definitely talk offline to you more about it. So I'm going to go through this. My build thing worked really badly, so I'm going to talk about this a little differently. So like I just talked about, GPON 2.5 by 1.24/1.25 gig. We actually deployed 1 gig services on this today. And you're probably going, well, how do you do that? Well, it's not really 1 gig. It's probably closer to 960 because of the overhead. And, it's a 1 gig Ethernet interface. But it's best effort, and it's a shared PON that really, at the end of the day, we're not guaranteeing 1 gig traffic. If this was SLA-based services, we'd have to do a completely different design. This is HISA. So this is how we deploy today. It's with a 7342. Let me put this on mute so it doesn't keep beeping. It's based for HISA. We have video from IPTV, but it's designed to support customers, a large number of 1 gig services on this single link. So we're doing that today. We have a significant deployment of this with 7342s and 60s from Nokia. As we do this, builds out. There's your 32 customers. Now we go to XGS. XGS is the 10 by 10. There is an option to do 10 by 2.5, but we pushed directly to 10 by 10. We felt we could get the volumes to get the price down. We did. So we're not even looking at a 10.2.5. The way that we make this business case work is we put it on 64-way splits. So right now the plan is for customers we can reach with the optical power budget, we're going to go do 1 by 64. So that means I can save a few dollars on the F1 plant because I'm now doubling up on my F1. I get also, and because the cost of the technology is still a little higher in the OLT, so the way we offset the cost is we offset it by the cost of the F1 plant. As you can see, it's 4 times greater in the downstream and 8 times greater in the upstream. It's our first really attempt at symmetrical PON. And so like I said, we're developing this. The last I heard was it's somewhere in the late 2018 timeframe is when we're lining up to push down the field. What else? And the big driver is multi-gig support. So right now today we offer 1 gig. As we look at with product, we're looking at 2 gig and higher. It's not really necessary that there's this suddenly something out in the network for consumer that's needed, but it is it's more to remain competitive when others in the industry specifically on the cable side push out multi-gig offers. That the technology is there to support it. We're not actually driving the multi-gig project. That's being driven out of product. And I apologize. I don't have an actual accurate timing on when they're planning to push that out. It will be after the technology gets developed, but it will follow this. Right now, what we're focused on the development side is to get the XGS solution built, and it will offer it initially with the same services we do today. But as product develops the next generation of product tiers, they can then use this technology for a multi-gig offer. Now, since I talked briefly about the 60s, or I've mentioned it as well, you won't see anything about the 42. The 42 is out there. We have thousands of shells that are 42s, 7342s that is. But they are we're only slotting cards. We don't put new shells out there. If they need a card for capacity, we put a card in. Right now, the workhorse since about mid last year, somewhere last, I thought maybe it was 2015. It's been a while. So we've been putting 60s out there at a very fast pace to support the 12.5 million build. So I think we've actually got more 60s than 42s now. So I'm going to talk about the 60 because that is a currently being deployed shelf. And will actually be deployed with the XGS as well. So as you can see here, we've got how this works. I wouldn't say this is absolutely 100% of the time accurate, but for the most part, the FX16 will go in the CO. So we always place an FX16 in a CO, and we use the FX8s only in cases where I need to put a remote. They have an FX4, but we didn't develop it. Mainly because these two shells, the only difference is the shelf density. The actual cards are identical, so I can use a line card in either shelf. I don't have to buy another set. So whether it's an FGLT-A or B, which are the GPON line cards, they go into either the FX16 or the 8. If I want to use the FWLT-B, which is the 8-port XGS card, it goes into either the FX16 or the 8. I don't have to have another set of cards that are unique for the remote system. The same common system cards are used. Everything is the same. Literally the only difference is the size of the shelf or the density. So as you can guess, FX16 means I've got 16 line cards. There are actually more slots, but 16 of those slots are used for line card support. And as you can see, there's 8 on the left and 8 on the right in the middle of the commons. In the FX8, it's 8 line cards. No big surprise there. I don't think there's anything else here that's of importance. Yeah, so I already mentioned, like I said, if you want to know if it's a GPON, if you see an FGLT-A or B nomenclature, that's a GPON line card. A's are end of life. That's why you see the B. We're getting ready to deploy the B, I think, at the end of the year. No major differences for what we're using it for. I would say technically there is there is the ability to support super jumbo frames on the B, but since I don't have a business service that requires that, we're not developing it right now. On the FWLT-B card, really the only big difference is it's XGS and it's only 8 ports. That's the max. They add an A card that we actually use in labs testing, but it will not be deployed in the field. So what you would see is if you see an FWLT-B nomenclature, that is your 8-port